Algebra students, Mr. Lawrence here with your flipped lesson, and today should be super duper simple. It should be 100% review. You've done it many, many times. It's all on the Pythagorean theorem, and after today's lesson, you should be able to say, I can find lengths and distances using the Pythagorean theorem. Now, one thing I want to stress, the Pythagorean theorem only works with right triangles. It only works with right triangles. What kind of triangles, Mr. Waters? Right triangles. It only works with right triangles. In fact, at the end of The Wizard of Oz, when the wizard gives the scarecrow the diploma, the scarecrow misstates the Pythagorean theorem. Yes, only math geeks would know that, but I am a proud math geek, and that is why I rule the world. Ha ha ha. Anyway, if you go and listen, the scarecrow will state the Pythagorean theorem, but he will say of an isosceles triangle, and it is not true. It has to be a right triangle. It could be a right isosceles triangle, but it must be right, not isosceles. Okay, now the most important part of the Pythagorean theorem, I know a lot of you know it. You can just say, well, I used a squared plus b squared equals c squared. And that's fine. A squared plus b squared equals c squared. But the most important part is c. C is not the side you are looking for. It could be, but it doesn't have to be. C is always the hypotenuse. Always the hypotenuse. It's the hypotenuse. Did I mention that C was the hypotenuse? Hypotenuse, which means it's the longest side of a right triangle. To find C, you find your right angle and you draw an arrow from the right angle. The side you hit is C. So this 25 is C. On this problem, the C is the unknown side. All right. Now, that's very important when you go to set up your equation. See, if I have a squared plus b squared equal to c squared, and I know c is 25, I'm going to do 25 squared. A squared could be 24, or a could be 24, and then b squared is unknown, so that's my variable. Okay, so I'm going to square, get 625. Oh, I want to say that that's 576, but I'm going to double check that. Hold on one second. Hold on one second. Let me pause so you don't have to watch. Good. So my insecurity was unwarranted. It is 576. I'll subtract 576 from each side. I'll get x squared equal to, let's see, looks like I'm going to do a little borrowing. I think that's going to be 11. That's going to be a 15, right? And so we're going to get a 9. We're going to get a 4. 49. Now to take the square root, and actually we're only dealing with the rad because we're looking for the side of a triangle. It's going to be 7 inches because the negative square root doesn't make sense for the side of a triangle. All right. Let's set it up for this one. I've got a squared plus b squared equals c squared. And again, I don't know c in this case, so it'll be x squared. And then I can do 8 squared plus 14 squared. I'm going to rewrite that. That doesn't look very pretty. There we go. All right. So I'll get a 64, a 196. That'll equal x squared. Now I know that 64 and 200 would be 264. So I think there's going to be 260 on the nose. And then to undo the square, I'll take the square root. Now, I don't know the square root of 260 off the top of my head. I know 225 is 15. I know 16 is 256. It's going to be a little bit more than 16. But I can go to my Google calculator and let me see here. Type in right here, I think. What am I doing? 260? Guess I got to press the buttons. 260. And then take the square root. Oops, it's not working the way I thought it was. That's okay. So I'll do that and take the square root. And I will get about 16 and 1/10. Of course, that's a rounded approximation. So x is going to equal approximately 16 and 1/10 centimeters. Okay. All right, one last problem, a story problem. A plane flies 40 miles north and then turns directly east and flies for another 40 miles. How far is the plane from its starting point? Well, first of all, the plane did something like this, right? And then he turned and flew directly east. And I know that he went 40 miles this way and 40 miles that way. I want to know how far he is from his starting point. So I want to know this distance. I'm going to call that x. Can you see the right triangle? All right. So now I find my hypotenuse, which is x in this case. So I can do 40 squared plus 40 squared, and that'll equal x squared. So that'll be 1600. That'll equal x squared. Add them together, I'm going to get 3200. And I'm going to do this one the long way. I'm going to go for an exact answer on this one. I'm going to take the square root of each side, but I'm going to simplify my rad. I know that rad 3200 is the same as 32 times 100. I also know that 32 can be broken down into 16 times 2. So this could be 10 times 10. And of course the 16 breaks down into 4 times 4. So what I have here is I have a 2. I have a pair of 10s who are going to go out on a date. I have a pair of 4s that can go out on a date. And they leave the 2 home alone. And so I'll get 4 times 10, which is 40. Rad 2, and that's equal to x. And that's my exact answer. If I actually wanted the distance, I could then do 40 times the square root of 2. I could do that. Let's do that real quick here. Where is it? Okay. So I'm going to go 40 square root of 2. Close that parenthesis, and there we go. About 56.6 miles, 56 and 6/10 miles. So, or x is approximately to 56 and 6/10 miles. I think in a problem like this, the 56 and 6/10 makes more sense because they're asking actually how far, and 40 rad 2 is a truthful answer, but it doesn't make as much sense to people. But you'll have to stop and consider what the directions say on which one you should do. All right, Mr. Lawrence signing off now. This lesson should be super simple. Have a good night, everybody.